Hello guys, welcome again, and this time I'm again as usual going to give the contest, weekly contest 459, this one, and let's see how many questions I can solve. I hope that I have not already given the contest. So the first question is check divisibility by digit sum and product. So you are given a positive integer n, which is this one. Determine whether n is divisible by the sum of the following two values. The digit sum of the digits, oh my god, the digit products. Return true if n is divisible by this sum, otherwise return false. Okay, so let me just obviously if what is going to be n is obviously going to be at most of 7 digits. So if it's of 7 digits, then the maximum product that it can be will be 9 to the power 7, right? Maximum product that there can be. So I think it's totally fine. It is going to work in a long int. So int sum, let's say it's 0, int product equals to 0, and what really I'll do is go towards the character. So let me make it a string. Well, I actually don't need to make a string. I can just simply do this. N is greater than 0, so I'm just going to add some n modulo 10. I'm going to add it. So let's call n modulo 10 as x. Okay, so I'm just going to add the x, and then in the product, let's say it's 1. Yeah. And obviously n cannot be lesser than 1, so yeah, at least product has to be 1, right? So product times equals to x, and then n divided by this one. Okay, so what I just need to do is n is divisible by this sum or not. Because of I am using the n and doing it, so I need to store the value somewhere and then check if. So just return temp modulo sum plus product, I guess, equals to 0. Yeah, I think this is what it should be. Let's try to run this. I mean, this was probably an easy question, is false. I think this will work as far as I'm understanding the question. Yeah, it did work. So let's try to do the second question. Count number of trapezoids, and I have no idea what trapezoids are. I know trapezium, but what are trapezoids? Are they the same things? We need to return modulos, so let's introduce the modulo at first. Const int mod, which is 1e9 plus 7. Like, this is what you need to do in the first, like whatever information you can get, just try to pinpoint it. Okay, so you are given an integer array points where points I is equals to x1 comma yi, it represents the coordinate of the point on the Cartesian plane. Okay, so x and y, are they always like positive? No, x and y can be negative. Okay, not that I'm afraid of negative numbers. A horizontal trapezoid is a convex quadrilateral with at least one pair of horizontal sides. Yeah, this is a typical sort of maths question, and those of you who don't know what convex quadrilateral are, the angle, the outside angle, it should be greater than 90 at least. Yeah, all of the angles that are there should be. If there are some angle which are lesser than outside angle, which are lesser than 90 degree, right, then it is sorry, 180 degree, yeah, 180 degree, my bad, yeah, 180 degree. If it's lesser than 180 degree, then it's considered concave. So if with at least one pair of horizontal sides parallel to x-axis, right, okay, at least one pair, correct, any pair, it can be any pair, right. So it just needs to be parallel. So two lines are parallel if and only if they have the same slope, that I know. Return the number of unique horizontal trapezoids that can be formed by choosing any 4 distinct points. Okay. So the all right. So how can we actually do this thing? Like, in order to do the things, I need to know how many points are there which are parallel to x-axis, right? So for those points which are parallel to x-axis, they will have this y common with each other, right? So their y's are common. So I just need to find all of those. Okay, before I do that, like there are going to be at least 4 points, yeah, okay, and all points are pairwise distinct, that okay, that's not the case. Like, is it always possible to form at least one horizontal trapezoid or not? That is what I am concerned about. If it's not, then I can just, okay, there are 2 distinct points, so yeah, I think I can do that. How do I, so the main question is, how do I actually, so there are a lot of y-axis, right, and there are a lot of points, and how many points are there? There are 10 to the power 5 points, okay. So one thing is clearly sure that this is going to be of combinatorics, like there is going to be NC2, NC2, something like that. So, but all those things actually we don't need to actually care about. If we need to find NC4, then we can just directly multiply it. We don't actually need to pre-compute anything, right? And in this case, I don't think even we need to find NC4, right? The only thing that we need to care about here is like duplicates. How are we going to address the duplicate values? So one of the algorithms that is coming into my mind right now is try to, for all y, y, there are going to be a lot of x's, right? x1, x2. So let's say for a particular yi, there is x1, x2, x3, right? And similarly for yj, there are also a lot of x's, x2, let's say x maybe 5, x4. A lot of x's are there for each y. So these guys, all of these x's are actually parallel to yeah, these y's are actually parallel. Right. So if these guys are parallel, this is parallel to x-axis. These points are also parallel to any 2 points. If you consider x1 y1 and x2 y2, they like x1 yy, x2 yi, they are all going to be parallel to each other, right? Okay, so now what we do, how many actually how many ways are possible to select any 2 points? It's the size of y, C2, right? Size of y, I, C2, correct? Size of y, I, C2 is the total number of ways I can select any 2 points which are parallel and they are of y. And now how many points are left, like they are left, how many points are left? So obviously when you choose the points, when you choose a trapezium, what you need, you don't choose obviously this same parallel line, like you cannot choose points here. So you will do total points minus size of yi, right? So these many points are left, and in these points I have to choose 2. So now you're going to see the problem is that there are going to be duplicates. So when I do this, there are going to be duplicates that I need to take care of. So I have to do inclusion exclusions to actually address this issue. And yeah, these are going to be multiplied by each other, right? Because you are choosing these 2, and then from the other you are choosing these points, right? But there are certain yj and yi, like when you choose for yj as well, you're going to get certain. So in order to address this issue, what you can do is, one of the ways is, I think that should work, is when you are considering this, whatever yi's which are lesser than this yi, you don't consider them because you have already considered those points before, right? Or you didn't actually. Okay, I am thinking what I can do. Okay. Okay, I'm thinking how can I solve this problem. Okay, I think I got it. Like, how do I explain this? So let's try to form another y. Let's say y. This is yk. Okay, yk. And this is something like x5, x6, or x7, or something like that. Yeah. So okay. So now this is what you're going to do. You are here. You did this thing. Okay, now when you come here, now what you're going to do, you are again going to do the same thing, but instead you are going to do this, but instead of size of y, you are going to do size of all of these guys over here. Okay, you are going to subtract those and then try to do C2, right? That C2 and then multiply it, but you are also going to leave some of the points which you didn't think in the upper direction. So oh, one more thing I think I need to take care of. So like there can be, it can be possible that one y is above this guy, another y is, so what's actually a trapezium? Oh, okay, shit man, I completely misunderstood the question. Okay, no problem, we are still going to solve this question. So there should be two, the total of one pair, and then there should be another pair which are parallel to each other. This is what actually it needs to be. So yeah, so this is how can you do that, how can we do this thing. um, yeah, we can just check these guys are there, these two guys, okay. Now let's say we have taken these two. Now we are not going to take anything above, okay, because any 2 points which you take above, it's already been taken down, right? It's already been taken when we were talking about the upper guys. So now you are only going to take all the down, right? Everything which is here. So this is how we do it. Yeah, I think this should solve the problem. So in order to do this, we need yi. As you can see, it's a lot, so I cannot store them in, but I can coordinate compress them. I can try to compress the coordinates, but it's still going to be low. So in order to store these guys, I think I should I don't think I should need to store anything, right? I just need to find out like common points, right? So n log n will work. Let's talk about map. I'll erase this in a while. So I really took a lot of time because of misunderstanding of the question, but yeah, MP of let's say these are y, and it's going to store what? Vectors, obviously. Not vectors, but a lot of points. It's going to store a lot of points, right? So yeah. So anti x equals to p of 0, y equals to p of 1. What we are going to do is y, we are really not going to do anything, we are just going to add it to this guy. Yeah, that's great. So now we know this, we know the size, we know this thing. What we need to do is compute this thing over here. So how are we going to compute this? Well, we know the size of yi, we know how can we do C2, right? So let's say the size of yi is so for auto xy, sorry, y and f, or maybe size, what we are going to do for each size, we are going to exclude, we are going to have this thing known as exclude. Okay, exclude how many points? Initially I don't want to exclude anything, correct? I don't really want to exclude anything. I am just going to take every point possible. But the thing is, I cannot take every point possible, I have to subtract this as well. So yeah, I can just explicitly do subtraction, that's not a big issue. So total points, how many points are there? So the total points is anti-n, which is this many points are there in total. So n minus size of yi, and there this is not going to be size of y, this is going to be exclude, right? So exclude okay, so initially okay, I think yeah, I think n is just going to be perfect for now. So what we're going to do, we are going to do this size times size minus 1 by 2, okay, and modulo this, okay. Now I am going to do times total points, which is n, but we are also going to subtract size of I, which is z, and this c2. So let me just make a proper function for this c2, like c, right. So this will be something like if r is lesser than n minus r, then r equals to n minus r, which is obviously not what's going to happen, but still, yeah. For answer equals to 1, what I am going to do, I'm going to do is less than equals to n I plus plus sorry r, yeah, answer equals to answer times n times I modulo mod, right? This is what it's going to be, and then n minus minus, or I can just directly say n minus I plus 1, correct. N minus I plus 1 is n, and then when I reaches only 1, sorry, r, then it's n minus r plus 1, right? Just r terms, that's it. And then return answer. So here, just instead of this big thing, I can just say C as J2, okay, and here also I can just say C 2, right, and then in the end I'm just going to do a modulo. So I'm going to store this somewhere, let's say answer 0 modulo mod, so answer equals to answer plus, yeah, mod, yeah, it's fine. So this should work, and in the end I am just decrease the number of points by size of this thing, okay, because I only need to care about those points which are below the point, below its 8, right? Maybe I can just do this here, so that I don't need to do this, yeah. Yeah, this should work, and let's return the answer. Just try to omit this. Okay, there is a little problem here. So it's whatever the answer should be, it's giving +1, which shouldn't be the case, right? I can just choose any 2 points, the remaining and what's wrong? Okay, and answer should be in long. That's nice. Okay, I'm taking a lot of time to solve this question. I don't know. Shouldn't be taking a lot of time. Okay, so take any 2 points. So let me try to dry run this. So 0 has 3 points, 2 has 2 points, right? 0 has 3 points, 2 has 2 points. So 0, 3, 2 and 2. Okay. So 0 has 2, 3, 2 has 2 points. Okay. Okay. Now what we are doing is that we are doing n minus n is 5, correct? N is 5, which is, we can see that. So n is 5, and here I can see that n minus 3, which is 5 minus 2, which is 2, right? So 2c2 is just 1, right? 1. We are adding it to the answer. So no, size, the size C2 also, like 3C2, which is also something like 3 times 2, right? Okay, in the end it's also doing something like 0C0, right? 0C0 or something like that. So like if it's 0, then I think I should not do anything, correct? So in the end, when it's coming here, so it's also like there are 1, this will give me 1, and this thing which is 0C2, 0C2 for, if so this will be 0, this is minus 2, and this will be n minus r, which will be minus 2 again, and okay, this should be giving me 1. Okay, so okay, if n is 0, just return a 0. Okay, so that's why it was giving the wrong thing. I think now it's dry run is clear. Yeah, 3 and 1, which is the correct answer. Let's try to submit this. What? Expected 0. Wait, what? Okay, yeah, I think this is also one problem that I didn't think of. Oh man, I'm not even thinking correctly. So if do this only if What if size is just 1? Size is just 1. If size equals to 1 or less than equals to 1, continue. Oh man, what am I even thinking? Output is 1. Okay. Yeah. Okay, so you know what I'm going to do for now, like if the sizes are 1, I'm going to erase them. Okay, that's what I'm going to do. Maybe I should store another map. MP2, right? And MP2 I'm going to work these things. If size is greater than or 1, then MP2 of oh, okay. Doing a lot of mistakes, actually. Yeah, I'm actually doing a lot of mistakes. It should be a parallel. Yeah, I'm doing a lot of mistakes. Yeah. Shit. This is going to take a lot of time. Okay, so one more thing that I forgot to do, which I thought but I forgot to do, implement it, is that two of them should be parallel to each other. So for all the otherwise which I have how do I collectively find the answers? Okay. Yeah, so first of all, let me just try to do it normally. Okay. So MP2, if Sj is greater than equals to greater than 1, then MP2 of y equals to Sj. Else I just don't do anything. Now we are going to work on MP2. Y Sj in MP2. Okay. So what we're gonna do, like we can do a path compression before, but let's not do that. Or I don't actually need a map, right? I can just have a vector instead. Vector p, maybe counts. So counts dot in place back. Let's see. Yeah, this is much better. Correct. Now I just need to find out in the counts these guys. So many guys, right? yeah, these guys which are going to help me. So what I'm going to do, I'm going to go to all of the axes in counts and just going to change them with x equals to c xe2, correct? Now each and one of them is going to give me a lot of things. Or maybe long. No, this should be. Yeah. Okay. Now when I have done that, I'm just going to come from the back and try to multiply each and every one of them on the counts. Or I mean add them, sorry. So for int I equals to n minus 2, or maybe counts dot size minus 2, so that equals to 0 I plus I minus minus, and I'll be like, okay, counts of I plus equals to is equals to counts of I plus 1 yeah, and maybe modulo. Okay. Now we have everything we need. We are just going to do this thing for int I, or maybe I should have stored some other suffix sort of thing here, but yeah, but because for count I need another variable. Anyways, okay, so from I equals to counts dot size minus 2 0 I is less minus minus, but yeah, we are going to do yeah, so counts of I answer, let me call the answer. Oh, answer is already made. Wait, what? Yeah, answer is already made here. So I'll be like, okay, answer is equals to count of I times counts of I plus 1 modulo mod. Yeah. I hope this will work. What? How is this not working? Have I become so bad at solving suddenly? Oh fuck, I forgot to add it. Shit, man. Again. So what's the problem? Okay, so what's wrong with this? Let's try to debug this. Okay, let me bring my mouse and try to debug. I just need to do it fast, man. I'm stuck in the second question. That's not good. So 26 has 1, 2, 3, 4, 5. So here we have, let's have 26. How much time is it going to take? Okay, so we have 26, which has how many? 1, 2, 3, 4, 5, right? So 26 has 5, and we have minus 3, 1 and 2. We have 10, 1, 10, 1. Okay, so now I am somehow not taking this. Oh wait, but what was the question again? To at least one pair of horizontal sides parallel to x-axis here. So I'm not taking this. So how many are there? It will be 5c2, right? 5c2 multiplied by 2c2, isn't it isn't the answer going to be this? All the answer that can ever exist is just this. For each of those two, I can take two of them. So 5c2 is how much? 5c2 is just 5 into 4 by 2, which is 10. So how come wait, what? So how come I am getting 8? Am I doing a mistake here? Oh wait, what? What am I even doing? This should be divided by. Fuck. So answer times this divided by that. And I am writing the formula wrong. Answer times -1. Why am I writing these formulas wrongly, man? Somebody tell. Fucking wrong formula. Oh man, I have wasted a lot of time. Anyways, let's try to do this fast. Okay, so okay, what is this? Queries. Popcorn set bits, okay. So the sequence, okay, smallest defined as smallest integer d such that this is one. For example, this, okay. So what is the question? You're also given a 2D integer array queries, query either 1 to 11. Okay, fuck. So query is of how much? Nums of wait, what? Determine the number of indices j such that the popcorn depth of num j is equals to k. Okay. So I just do the, what do I do, like dp again or what? 2 means update the, okay, segment tree and dp. For each of the nums j, I think it is nums j is 10 to the power 15, and as far as I can recall, I was doing this is with digit dp, and I think it was digit dp will not work here obviously. Shit. So what can we do now? Is 2 to the power, it's going to take 2 to the power 15, or not even 2 to the power 15, it's going to take 2 to the power 64 at worst case, or These questions are like very, very tough. Obviously, this time my rank is going to be very bad, yeah. Because of mistakes that I did. Only 2 questions I solved. I need to find out the number of windows L to R such that the pop count depth of null j is equals to k. Okay. Oh. Okay. Can I use something like Fenwick tree or segment tree? I think I can, right? From L to R, if I try to find out how many of them has, so it is going to queries are of how much length? Queries are 10 to the power 5. So I need to do this is in log n. So how can I do this in log n? Obviously segment tree and something like that I need to use, but how? Okay. If I have a k, then I just need to find out how many are there which has length k. Okay. Obviously the depth k cannot be more than 5, okay, right? So I can just use a hash map. Okay, I can use a segment tree, or maybe even a Fenwick tree will work. Fenwick tree, I think I should use Fenwick tree because I've never used Fenwick trees, or maybe I should just use segment tree because so let me quickly build a Fenwick tree. Okay, so in a Fenwick tree, I will have the hash, which is going to be not more than 6, I guess. So int maybe vector hash, which is going to be, let's say 7. Okay. Now from L to R, I need to check how many of them are 4, how many of them are 5, right? Like from 0 to R, how many of them are of length k? That I need to somehow know. So if I try this hash, this is only going to tell me how many numbers are in overall, how many numbers are there with this particular hash. Okay, with overall how many numbers are there with 4, how many numbers are there with 5, it's going to tell me. I just need to, even if I try to do this, here to here, how many numbers are matching with K? From here to here, how many numbers are matching with K from 0 to R? How do I find it? Okay, I think I can use something like this. A vector of vectors v, right, which will be nums of length int nums dot size, right? And here what I'll have is something like this, because this can never go more than, K can never go more than 6, so I'm like, okay, 6, this is what I'll do. And for, let's say for this n, I'll try to do n times 6, so that I store for everybody I store the number of so what I'll do, first I'll do this. This will be not long, but okay. So first, for long x in nums, I'll be like, okay, so while x is greater than 1, let's say that count equals to 0. Okay, while x is greater than 1, I'm like, okay, x equals to, if it's already 1, then count is 0, then, but if it's not 1, then I'm like, okay, what is the count? So x will be almost like built in pop count x, okay, and then count plus plus. This is what it will be. Yeah, and when I see that x is equals to 1, we can also see clearly that nums can never become 0, so we are fine here. And x is now equals to count. This is what I'll do. I'll change these guys with these guys for first. Okay, now what I'll do, for di equals to 0 is less than plus plus, I'm going to do this thing, like v of I of nums of I plus plus. Yeah, that's what I'll do. And once I do this, this will be done when I can just directly make the Fenwick tree now. So Fenwick tree will have this thing and overall. Okay, so now I'm like, okay, so I'll at first I'll add to the Fenwick tree. So I'm like, how to add in the Fenwick tree? Fuck, I forgot. Should I do like segment tree instead of Fenwick? but I actually want to learn Fenwick trees, that's why I'm doing this. Okay. Okay, so let's say that I want to add void add in let's say in this index I want to add x. Okay, so when I want to add x in this index, I'll be like no, actually I don't want to add anything in the index. I want to change that index, okay, with this value, let's say. So first I need what the value is it's talking about. So once I get the value, I know what is going to be its cost. So let's say that the cost is x. So at first I need to change the previous value that int had. So previously int had some number. Okay, so what number int had? So let's try to also store this guy over here as well. Ah man, I think I should use segment tree. Segment trees can do it. I don't think so. There should be a lot of segment trees. There should be 3 segment trees, right? When I tell the so 6 segment trees or Fenwick trees, okay, so I can just add the previous value here only directly, and I'll get that what previously this guy had. I'll remove it. So this is let's say k. Void update, let's say this will be, I'm going to update this with the value of k. So end k is going to be plus added by 1. So that segment tree which has all k's, I'm going to update that by 1, right? That's what I'm thinking currently. So instead of this, I will say this thing here. So many, right? And now I'm like, okay, after I do that, I'm going to add end of k by 1. K by, let's say, some value val. Okay, add it with this value. So how am I going to do that? When I add, I have to add to all of those places where this guy actually occurs. So if I want to add at this end, in the tree. So this is not the tree, right? This is actually not the tree. So the tree should be of how much length? Like okay, I'm trying to, because see, I don't actually know Fenwick trees. That's why I'm just trying to, I can easily use a segment tree, but I really want to, use Fenwick tree, and that's why I'm doing this. So this end is actually going to store the value from just the previous, when you, the last set bit, when you remove it, from that plus 1 to the this bit, it's going to store the sum. Correct? Okay, this is clear for clear. Now so let me make it bit. Okay, this will be more clear. Now I want to add n to the all of the strings, right? So I'm like, okay, if I want to add this, then for int I equals to end, I is less than n, and also it's going to be almost with one index, so this will be something like this. So end here I am going to put in plus 1 actually on the, okay. What I'll do here is bit of I. So here I'll be like, okay, I'm going to add to the I the last bit itself. So what is the last bit? The last bit is simply I n minus I, right? This is the last bit, it's the last set bit, and in the I am just going to add that particular thing, and yeah, this is what I'm going to do, bit of I plus equals to val, right? And I don't know if this is going to be long or not, but I think it's going to be integer value, yeah. And actually I am going to go to case value and then add this value, right? That's what I need to do. And so I am just going to do this, and when it will be updated, at that time I'll query this query, or maybe find int end. So it will give me from 1 to end how many of them have the k. Okay, so I'm like, okay, end. So for I, so I is just going to be equals to I and I minus 1, correct? So it's something like this, I and equals to I minus 1. So I is just going to be AND with I minus 1, and then it's just going to. So this will be sum plus bit of I plus equals to, yeah. And now it's going to give me the sum, and then I'm just going to return the sum, right? So this is the Fenwick tree that I'll need. So I'm also going to have a constructor here which is going to tell me. So Fenwick anti-n, so bit six comma vector int n plus 1, right? This is what I'll do, and here I am just going to do Fenwick of n, right? Fenwick f of n, right? This is going to give me all these things. After I have these things, I'll just try to, these nums, I'll just try to add this update in this value. So for long and x in nums f dot update, what I'm going to do, I'm going to update the index, right? Index of I. Okay, so this will be 0 I is less than n I plus plus, yeah. So I plus 1 nums of I with 1. Okay, this is what I'll do. So this is solved. I have all of these guys over here, and now we are into our main thing. Why is queries in long? I don't understand. IDX of value, oh, changing the value, okay, right, yeah. Yeah, so anti q equals to queries dot size for anti I equals to I q I plus plus. So I am also going to have this vector answer where I am going to answer the queries. So what queries do I need to answer? Where answer I get the type of thing. Okay. So if queries of 0 I of 0 is equals to 1, then what I'll do, I am just going to answer dot emplace back, Fenwick, I have f dot find L and R. L is, I think, what is L? L is 0th index, yeah. So it will be R plus 1 minus f dot find L, right? I am just going to subtract the L's. One thing that I need to be careful of is that from L to R, the find is like I need to find k, right, end of k. So anti L equals to queries of I of 1, I need to be faster, R equals to queries of I of 2, and k equals to queries of I of 3. Okay, now here is the thing, like R and L are just so from R plus 1 is going to give me from 0 index to first index, and if it's already 0, right, find is already 0, So yeah, if it's 0 then don't just return 0, right? So this is going to work. And anything else do I need to do? I think yeah, this thing, okay, right, that's it. This is what I'll do here. And if something else, like I need to, if idx idx equals to queries of I of 1 and val which is of queries of I of 2. Here what I'll do, I'll try to find out this thing, what is the value actually, while val is wait, long right. So while val is greater than 1, I'm like, okay, val equals to built in pop count of val, right? And then count plus plus. Okay, so when it reach 1, I'm like, okay, count. In the idx, okay, so in the idx I need to at first f dot update the idx plus 1 with idx can be 0, right? Yeah, 1 in 0th index plus 1 of nums of idx, right? So nums of idx I need to subtract, add this thing, and then f dot update idx plus 1, I will add this count here 1, that's what I'll do. And then in the end I am just going to return answer. I hope this works. I don't know, there will be a lot of, yeah, so n is this dot n equals to n, yeah. Okay, yeah, so k of bit, two 1 which is correct, 310 which is also correct, 101 which is also correct. So please work. Okay, didn't work, sadly. Man, I don't really have time. Yeah, what's wrong? Nums equals to 8, and if it's 8 then to the index to 8 only, so I'll subtract. Okay, at first, oh yeah, I forgot about this one. Nums of idx will be count. right? I forgot about this one. Yeah, please. Oh my god, what's happening? What the heck is happening? Fuck, man. No idea whatsoever. I literally have no idea what's happening. LR this thing well, and I'm going to try to find out long nums of I equals to idx dot update idx plus 1 with count 1. Finwick tree is not working, or am I, did I write this wrong? Okay. Fuck this thing. Shit. Again a wrong answer. I'm pissed now. I and this, and I'm adding that thing to I. Or maybe does it want it in really I and I minus 1, I think. This is how I get that particular thing. Oh fuck. So many penalties today, guys. Time limit exceed what? Are you kidding me? The I and I minus 1. How can it keep time limit exceed? On which test case? First test case. तो जब मैं ये करूँगा तब क्या होगा, तब एंड होगा सबका उल्टा, मैं ऐड करूँगा इसको 1 में, ये हो जाएगा, एंड करूँगा तो ये हो जाएगा। तो इसको भी देना। यहाँ पे क्या हो रहा है, what the fuck. Oh shit, I got it. I think because it's a long, I need to do pop count ll, right? So I think this is all right. Minus I. It's okay. I don't know at this point what to do. Yeah, finally. Please. Yeah, that's what I'm talking about. Fenwick trees, guys. I learned Fenwick trees. Yes. Wait, what? Oh my god, this too. What the fuck? I just need to have parallel sides, that's it. Now how can I find the parallel sides? Okay, this question is like very mathematical. I wouldn't have done it, but yeah, it is what it is. So I learned to, use Fenwick trees, guys. That's a big achievement. And thanks for watching. I don't think I will be able to solve this. It's just, I need to think too much and I don't have that much time. So I hope you guys enjoyed.